In the last lesson, we learned how to set up and apply weather modeling to our schedule. In this lesson, we will learn how to understand and apply percentage lags and leads to our risk model. In deterministic schedules, the use of lags and leads is normal practice, but we should always try to keep their use to a minimum. The use of relationship lags and leads is sometimes unavoidable, particularly when developing a deterministic schedule that is going to be used in a risk analysis. When lags and leads are used, we often create actual activities to be used instead of a particular lag or lead. This is a good approach because it makes the lags and leads very visible on the schedule. However, when there is a lot of unknown information about the activity and associated risks, it is advisable to turn fixed lags into percentage-based lags. Primavera Risk provides a means for turning fixed lags and leads into percentage-based lags and leads. The percentage is calculated based on the uncertainty of the activities. So if a percentage lag is used, a reduction or increase in the activity duration during simulation will then increase or reduce the duration of the succeeding lag. Let's quickly build a short dummy project to see how they work. So select File, New, and the New Plan dialog window will open. Select the icon for New Plan and click Open. A blank Gantt chart will open. Enter the following 3 activities and durations. 1, 30 days, 2, 20 days, 3, 5 days. Now, using your mouse, drag a Start link from 1 to 2. Drag a Finish Start link from 2 to 3. Then drag a Finish Start link from 1 to 3. Now you have a simple network diagram. Adding a percentage lag or lead is very easy. So, to add a lag or lead to a succeeding task, we highlight Activity 1. Select the Links tab in the bottom window. Then in the Successes pane, you'll see 2 successes. In this pane, for Activity 3, select the cell under Lag, and you could type in the required lag or lead, a positive value for lag and a negative value for lead. That's the usual way for entering lags and leads. Now we want to enter lag as a percentage, so type in the value with a percentage sign after it. We'll type in 40%. Activity 3 will now have a lag of 40%. A percentage lag can be greater than 100%. This simply means that the lag is longer than the duration of the task. Note that a percentage lag cannot be entered on a link to a summary task. Let's return this lag to 0, so simply overtype a 0 in the lag field. Now, you can also globally change all of the lags in a schedule. For example, fixed lags can be converted to percentage lags or vice versa. So, we'll enter the following lags into our schedule. Highlight Activity 1, then in the lags field of the lower successes pane, highlight Activity 2. Type in 8 days. So Activity 1 has a start lag with Activity 2 of 8 days. Now highlight Activity 2 and give it a Finish Start lag of 10 days with Activity 3. We now have our lags in days and we want to convert the durations to percentages. To do this, you would select Risk, Percentage Lags Quick Risk from the top menu. The Percentage Lags Quick Risk window will open. Here you can apply the change to all tasks in the plan, all filtered tasks, or selected tasks only. Let's convert all tasks to percentages, so keep the first option selected. The next option lets you change the link details, so we can convert fixed lags to percentage lags. This will be based on the current lag and current task duration. Make the lag a certain percentage on all links, or convert percentage lags to fixed durations. We want to convert all tasks to percentages, so select the first option. Click OK to make the changes and the dialog window will close. Click Activity 1 and you'll see that its start lag with Activity 2 is now 26.66%. Highlight Activity 2 and its finish to start link with Activity 3 is now 200%. Now let's reverse this procedure. So select Risk Percentage Lags Quick Risk from the top menu and the Percentage Lags Quick Risk window will open. Make sure that all tasks are selected, then select the option for Convert Percentage Lags to Fixed Durations. Click OK to close the dialog window. You'll note that our lags have now been converted to durations. The same procedure can be used to convert individual tasks to percentages or vice versa. Close the Gantt chart window and don't save the example. So in this lesson, we learned how to understand and apply percentage lags and leads to activities, both individually and globally. In the next lesson, we will learn how to use and apply probabilistic links and probabilistic branching. In the last lesson, we learned how to understand and apply percentage lags and leads to activities, individually and globally. In this lesson, we will learn how to use probabilistic links and probabilistic branching. So what is a probabilistic link? It allows you to model the probability of the link between two tasks, existing or not existing. When we create a schedule, certain assumptions are made regarding the workflow, even if two tasks are linked or unlinked. For example, say we have a link between an approvals activity and a construction activity. In the initial stages of the project, we might have assumed that approvals are required before starting construction, but we are not absolutely certain. So we can put an estimate on the percentage probability that the approvals will be required to start construction. Then, during the modeling process, the link will only exist for the percentage of the simulation through approvals to the start of construction. So let's create a simple example. Select File, New from the top menu. In the Templates window that opens, select the icon for New Plan, then click Open. A blank Gantt chart window will open. Enter approvals in the first description field, then tab to the next cell on the right. Enter 32 days for the duration and click Enter to move on to the next activity. Now enter construction for the second activity and give it a duration of 64 days. Link the two activities as finished to start by simply dragging the link from the end of approvals to the beginning of construction. Now in the bottom window, select the tab for Risk and Uncertainty. Another row of tabs will open up below it. Select the tab for Probabilistic Links and make sure that the checkbox for On is selected. First, we need to select the succeeding link. So select Construction in the Gantt chart. In the bottom window, you will see that the preceding link, Approvals, will appear in the window with a default value of 100%. We want to allocate a percentage probability. So enter 25 under Probability and press the Enter key. You will note that we now have a total of 75% left to allocate, and that's okay. That's all there is to it. So close the file, but don't save it. Now, probabilistic links are useful in simple modeling when it is uncertain whether two tasks are related. However, more complex modeling may need a different approach, and this is where we use probabilistic branching. So, probabilistic branching can be applicable when there are two or more parallel exclusive paths to accomplish some part of a project. In this situation, we have not yet chosen which path to take. For example, probabilistic branching could be used to model the difference between modularization and stick building in a site construction situation. So each path or branch is assigned a probability of existence, but the sum of the probabilities of all branches must add up to 100%. When a schedule risk analysis is run, Each pathway or branch is randomly sampled according to its probability of existence, including all successes in the branch. Let's create an example. We are digging a hole and we come across an old buried insulated pipe. We are not sure if the insulation is asbestos, which will require expert removal. So we have three options: insulated pipe found that needs expert removal, insulated pipe found that can be removed immediately, or ignore the pipe and dig normally. So select File, New from the top menu. In the Templates window that opens, select the icon for New Plan and click Open. A blank Gantt chart window will open. We'll create a simple schedule for our probabilistic branching, as per the table on the screen. So we'll enter the following list of activities: start milestone, remove top layer, insulated pipe found, requiring expert removal, expert removal, insulated pipe found, remove immediately, dig normally, fill hole, finish milestone. Enter the durations and links as per the table on the screen. I've speeded up data entry and will show the finished schedule. Select the single preceding task for the branches. This will be remove top layer. In the bottom window, make sure that you have selected the Risk and Uncertainty tab, then select the Probabilistic Branch tab. You will note that the three successes are shown. Let's enter a probability for each of the activities. For dig normally, enter 75%, then remove pipe, enter 15%, and for requiring expert removal, enter 10%. You will see that the total left to allocate is now 0 and is green in color. All of the probabilities must add up to 100%. Now click OK and save the plan as Probabilistic Plan. We now want to run a risk analysis to see the effect of probabilistic branching. So select Risk, Run Risk Analysis from the top menu, or select the Risk Analysis icon in the top toolbar. Make sure that we are showing step-through analysis, then click Analyze. As you step through the analysis, you will see the tasks disappearing and reappearing. This shows the effect on the risk model. Click Complete to finish the analysis. After the analysis, you will have three outcomes for the project dates and project cost. Close the file window and don't save it this time. So in this lesson, we learned how to create probabilistic links and probabilistic branching. In the next lesson, we will learn how to format our Gantt chart. In the last lesson, we learned how to create probabilistic links and probabilistic branching. In this lesson, we will cover the most commonly used options and formatting for our schedule during our risk analysis. We can use any of our plans to look at our different options. So I have selected File, Open Recent, Probabilistic Plan. Now I mentioned earlier that Primavera Risk was originally developed as scheduling software. When the risk analysis component was added, they were merged into a single package. We will look at the following options under the main menu: Format and Plan. I will select the most commonly used options that we will use for risk analysis. Select Format Timescale and the timescale window will open. You could also right-click on the Gantt chart timescale to open the Format Timescale window. Click on the Display tab. Here you will find options to choose your scale, timescale display, and week number display. Now select the Format tab. This will allow you to select the font type and size, as well as their color and background color. Then select the Lines tab. This provides options to change the styles of vertical lines between hours, days, weeks, months, or years. Lastly, the Data Date tab allows us to format the color, thickness, and type of our data date. Click Cancel to close the timescale window. Select Format again from the top menu. We will ignore Format columns because we covered this topic earlier in the course. So let's look at Format lines. This allows us to change the line style and color and gives us the option of choosing alternate row colors. Next, click Format Gantt Chart. Here we will have different tabs to format different areas of the Gantt chart. We can also access the Gantt formatting by right-clicking in the Gantt chart area. Click the General tab. We can choose whether to show or hide the Gantt chart. We can also set the color before and after the data date. Now click the Task Details tab. Under Task Options, we select the option to ignore any individual task styles that have been set and only use the default styles. We can also hide the normal bars and only display custom bars that have been set up. Next, we can show the criticality at the start of a task. This option will allow you to identify tasks that have a critical start rather than a critical start and finish. The start will be marked with a red symbol. Next, we can elect to show float and % complete in the schedule. Lastly, we can elect to highlight constraint dates on the schedule. A yellow circle represents a constraint, whereas a blue circle represents a nudge date. Click the Baseline Bars tab. This allows us to select whether the baseline bars are shown on the schedule, as well as their format. We can also show or hide baseline bars using the icon in the top toolbar. Next, select the Downtime tab. The checkbox allows you to display or hide downtime, such as non-working days and weekends. If you show exceptions only, you will show exceptions such as public holidays. You can then select how you would like the downtime to be displayed on the Gantt chart. We can also show or hide downtime using the Show Downtime link in the top toolbar. Next, we'll select the tab for Curtain Downtime. Here we can select the color of the curtain that displays our downtime, and we can select a calendar for our curtain downtime. Note that this will not affect our scheduling. Next, the Links tab provides us with options to display or hide our task links, as well as their colors. We can also choose the Show Links icon in the top toolbar. Lastly, the Risk tab allows us to format the display for different risk options, such as distributions, probabilistic branch links, and task existence. We can show or hide risk distributions by selecting the Show Risks icon on the top toolbar. Click Cancel to close the window. Let's select Format Bars to open the Bar Attributes window. Click the Bars tab. Here you can change the styles and colors of task bars, float and % complete. If you select the Tasks Font tab, you can edit the fonts and colors for different types of tasks or milestones. The last tab, Task Text and Symbols, provides the option for annotating and positioning text on the bars, with text from pull-down menus. We can also provide graphical symbols around the bars. Click Cancel to close the window. Now, let's select Planning Unit from the top menu. A small window will open where we can change the planning unit for our schedule. Click Cancel to close the window. Next, click on Plan Options from the top menu. We have already looked at the option for the Date tab earlier in the course, but it is useful to recap all of the display options. Next, the Time tab provides options for displaying durations, time periods, and calendars. Most of these options will be set when we import our schedule, but we need to be able to make adjustments if necessary. Next, the Currency tab will allow us to change the options for our currency. The Preferences and Default Task tab options can be ignored for our risk analysis. The last tab is for scheduling preferences. Once again, most of these preferences will be determined by our imported schedule. As a rule of thumb, I generally make sure that I select retained logic and early start. For the lag calendars, my preference is to use preceding task for start and start-finish tasks, and succeeding task for finish start and finish tasks. Next, we can select stretch, only if start of task has a successor. For hammocks, select span the entire plan. Lastly, for critical tasks, we can use total start float, but again, we would most likely use the values from our imported schedule. Click Cancel to close this window. You may wish to take part in my other courses for Primavera P6 for beginners, Primavera P6 Intermediate, Deltec Acumen Fuse and 360, and Deltec Acumen Risk. The next lesson covers a risk analysis exercise where you can apply the techniques you learned from this course. I recommend that you complete the exercise and apply the principles that you have learnt from this course. Thank you.